right, so we'll move on to our solar eclipse roundup. And our first speaker is going to be Chris Jolie. And let's use the microphone so that, come on up, so that we don't waste time hooking up everybody with this other microphone.
Right. Sounds like a plan. All right. Hi, everybody. Good evening. My name is Chris Jolie. For those who don't know me, I'm an amateur astrophotographer, and I've been doing this since 2012. And I'm going to talk about my time when I've done my experience with the solar eclipse at the Ontario Science Center. And unlike last month's speakers, I did not see the full eclipse. I saw the partial eclipse. And I was very disappointed, but a week later I went to Bermuda, so it's a good trade. Yeah, so my morning started off waking up, showering, brushing my teeth, and getting ready to go. And the first thing I had to do is get some solar glasses for my brother, because he was hell-bent on seeing it with or without glasses. So I got him those glasses, and then I came straight to the Ontario Science Center and set up my telescope. And I'd like to thank Sean for helping me out with that, because I had the tripod, the mount, the OTA. I also had the battery and so many other, and the solar filter, and I had to make multiple trips to actually get it from my car, which is parked in Lebanon, and bring it all the way to the area. And thank you very much. And that day it was a crowd. It wasn't like nightclubs are filled. Nightclubs are not as filled as how many people there were at the Ontario Science Center that day. It was packed, and there was big lineups for the solar eclipse glasses that the Ontario Science Center was handing out, but also there was a lot of lineups for people to look through telescopes of the volunteers that were there, and it was very interesting. So when I got there, I set up my telescope up there, get the tripod on, get the mount on, get the OTA, align it to the sun, and get ready. And by then, already a lineup had started to form. And I didn't realize I was going to be showing this to everyone, but I ended up doing it anyway. And a lineup came in, and I shared my telescope with everyone. And it was really fun. It was really interesting to see all the passion in everyone's eyes. And some people really were grateful that I was there, because all the other telescopes were taking 3 hours to get to, and mine was taking only 30 minutes. So I was like, wow, how's that possible? Well, I guess there's that many people. So yeah, everyone was looking through it left and right. There were some good conversations that I had with some of the observers there, and it was good. By the time we got to mid-eclipse, I had to kind of tell people, wait, I got to take my pictures. So I got I got my pictures, and then I continued. And by the time the moon was on its way out, people were starting to get antsy, and they were complaining like, when are we going to see the moon? And I was like, okay, you got to cut it down to 30 seconds per person, okay? And then to 20 seconds, and then to 10 seconds, and then no pictures with your cell phones. And then by the time it all ended, the eclipse was done, and whoever missed it, but no one really put up a fight or anything. So it was good. No one got hurt. But two things happened that were interesting, not related to the eclipse, but good things. Like two people. I was really parched at the time, and two different people got me bottles of water, and I was really grateful for that. And also, a gentleman came in with a camera like that, a microphone like this, and be like, "Are you a scientist?" And he's like, "No, I'm a business student." And I just tell them like how it is. Like this is a hobby of mine. I really enjoy this, and and I definitely wanted to keep this going. And he's like, thank you very much. I don't know what he did with the footage. So now that everything is done, and once people were just going to look at the sun, and I lost the sun a few times, but by the time I lost the sun and I can't find it again, it's gone behind the clouds, and I started to pack up. And by the time I was getting ready to go home, one of the Ontario Science Center people, I believe her name was Rachel, right? I don't know, but they were looking for pictures for Global, and they got my and I was able to give my pictures in, and I don't know if they were used, but they're there. And then I packed up and then drove home. Like I was gonna give some people some rides, but there was not enough space in my car for everyone and my telescope, so it is what it is. And then I went home and regaled to my dad. And that was pretty much my experience for that time. And overall, it's nothing like seeing a full eclipse. That was quite like watching YouTube videos of people enjoying it was great, but it's not the full eclipse. And also, watching a partial eclipse was fantastic, but it's nothing like a full eclipse. But this was good training for the next eclipse. Thank you.
Thank you so much, Chris. And we'll call on Vikas, Nath, and family for their report on what they saw during the eclipse.
Hello, my name's Artash. And my name's Avushi. And we're going to present you about Solar X, which is about measuring data from the last 2017 eclipse using Solar X. So we had lots of questions about the eclipse. During the eclipse, will the temperature drop? Will it become more dark? And how much more dark? So to answer these questions, we created Solar X. Now, like all our projects, Solar X started with paper and pencil. We designed how exactly would we want Solar X to do, what are the sensors we would put in Solar X, and how exactly would it work. Then, as we knew we would have to carry Solar X around a lot to the places where we were going to see the eclipse, we went around the house to find a box or something that could contain all of the sensors that we had. So we ended up finding a lunch box that we would attach the sensors to. So then we added the sensors. There are lots of sensors: infrared sensors, visible light sensors, ultraviolet sensors, temperature sensors, and a solar panel, so that we could actually see what's the difference in power as the eclipse happens. This is Solar X. So these are the sensors. And this is actually an SD card module, so that as the Solar X is on and measuring, it'll automatically store all the data inside the SD card. And also a time module here, so that it can also give a timestamp so we know when exactly the measurement was taken. So then, of course, we had to code all the sensors to the Arduino chip. So, and here is an example of the front of the code that we used. So after this, we had to test it to make sure no mistakes would happen during when we're actually measuring it for the solar we found out that lots of people actually travel to see the solar eclipse, and we did some research and found out that Carbondale was the place where there would be the maximum amount of totality. So we decided to go to Carbondale. Now, Carbondale and Toronto are not very far from each other, only 1,300 kilometers approximately. But we decided to take a small detour, going 8,000 kilometers extra than we need to. So we took a plane first, Toronto to Victoria. Then we took a boat, Victoria to Seattle. Then we took a train, Seattle to Sacramento. And then we took another train, Sacramento to Carbondale. When we arrived at Carbondale, it was the middle of the night. And we were very surprised the next day to see lots of eclipse activities everywhere. Then, to get to know more about what we were going to actually see, we attended seminars talking about the eclipse. And then we went to a stadium, the Saluki Stadium, and we saw lots of expositions from stalls from the NASA and stalls from other science companies. And after that, we visited the Southern Illinois University, where we met the dean of the university, and he was really interested to know about Solar X. And he asked us, what is the sampling rate of Solar X? And it actually turned out that he was also Canadian, from Calgary. So then, now the sampling rate of the Solar X is every second. You might wonder why it's every second, and why so short amount of time. But in solar eclipses, things seem to change really rapidly. Like suddenly the darkness darkens and temperature drops. Then finally, and we also got baseline data, so that we could be more precise. So the day when we would actually measure everything, we would get a better idea of what are the measurements. So finally, the big day had arrived. We went to Arctic Spike, and we set up all our instruments. Like, we put Solar X in the shade because we don't want to measure the temperature of the direct sunlight, because that'll make it imprecise and really high. So we put it in the shade to get a better average reading. And yeah, so then we watched the solar eclipse. And at the end, we had actually got 22,000 lines of data, approximately, from each of the sensors, so around 150,000 data points. After this, we wanted to analyze our data to get a graph. So we plotted the data, and this is the graph of the light and the solar voltage output. So you can see that the light dropped around 35%, whereas the solar output actually dropped 95%. You can see they dropped at around the same time, at around 140 or 120 actually, and that is actually the moment of totality. The next graph that we made was plotting the infrared and the temperature. The temperature dropped 13%, and the infrared dropped by over 85%. And again, like the previous graphs, at 1320, it's the maximum, the least data, the measurement of data. And then we decided to use the NASA Globe app, and we actually saw an organizer of that. it said that every 10 minutes you should measure the temperature, and every 20 minutes you should measure the cloud cover. And this is what we got. You can see it's dipping. And when it was totality, it became very dark. The insects were chirping, birds going to their nest. And this is a short video of showing like the instruments that we had put, including instruments that we used to measure the wind and picture solar X. Also a fast-forwarded video of the skies around the time of the eclipse. So this is where we had put the base. Here is the thermometer that she used to measure the temperature and to put on the glow back in the shade. And here is Solar X that kept recording automatically the data.
So the balloon is
Now
saying
here
that the
is
wind
you have
direction
seen
has
the
changed
balloons
from,
early in the
it's going
pictures.
from
Now
south
we're
to
actually
north. So the
moving
wind is roughly, it's southeast basically. It's a southeast wind right now.
So, yeah,
And
you
the
can
wind
see
has slowed down.
Motion is it tilting in to get the wind direction. This is a picture of the skies around the eclipse time. So it's not yet totalities yet. You can see that there's a big cloud. And this is a picture I got from my camera of the eclipse with an eclipse filter in front of my camera. And as I told you, the big cloud went in front of the sun, so we couldn't actually visually observe totality and diamond ring or Rayleigh speed. But we will be back because in 2024, Carbondale is actually the crossroads of the 2024 eclipse. Thanks. And we thank the Royal Astronomical Society of Canada for keeping us excited about space. And thank you, that's the end.
Any questions?
What did you use to power your Solar X equipment? It wasn't just from the solar panel, right?
No, we are connected using this USB cable to a laptop, and we could actually also see from a serial monitor the data getting plotted. Yeah.
So I have a question. Back when you showed the graph of the, I think it was the infrared radiation, and yeah, that green spike at 12:45 or so, any idea what caused that?
Well, sometimes like we moved Solar X a bit,
Oh,
and like because of the wind, the tree, the shade of the tree above maybe moved, so some direct sunlight might have.
okay, thank you. Thank you. That was a real mystery. I couldn't figure it out.
Actually, it was a very much of a difficulty for us to keep moving because the shadows kept on moving.
Yes.
And we had to actually keep the Solar X in the shade. I mean, we tried our best to not to touch it, but sometimes the branches would move because of the wind. And we actually had taken, it was our birthday in the train, but we used the balloon as a wind vane because we were trying to understand which direction the wind was going. So I actually had about 70 observations written, which we are hoping to get it published eventually, to understand how much data was collected. In fact, in Carbondale, they were also sent some of the sensors on the balloon altitude, so we are planning to have a cross-linking of the data of ours from the ground level, as well as getting the vertical separation of the data. So we are hoping that, we were very much interested in the science of the solar eclipse. So we are thinking that eventually, more than the visual observation, we are able to understand that. And the idea is to get some kind of a heat equation of the Earth, basically, that in 3 or 4 minutes, if it can lose 5 degrees, how much, would be the factor of the equilibrium, basically. So we are hoping to continue this project.
When you said it was in the shade, were you just using the leaves on the trees to shade it? Did you have a screen?
No, we didn't use a screen. We just, because it was an open park, it was...
So if the leaves were moving or the branches were moving, then the amount of shade could...
Yeah, it was a good enough tree, but the whole idea was that after some time, if it was a very big wind, then there might be some canopy, there must be some light filtering through the canopy of the tree. But for most of the person, if you look at the graph, it's fairly stable, and the dip actually starts at 1240 basically. That was the time when the totality was about 30%, because before that the impact wasn't too much, and then the dip really happened very smoothly in the other graph. We have 2 or 3 other graphs actually, we didn't want to put it up there, but we are hoping that in the paper we would be having, because we have a lot more data than we can handle actually, which is a good thing for us.
This is really impressive.
That's a lot of data.
And it costs around $80 for us to make this actually. So it's not a very expensive thing, and it's a very hardy one. We have used it to demonstration grounds and other places. Thank you.
So while you were collecting the data, how did you guys enjoy viewing the eclipse?
Well, we didn't actually have to operate the Solar X while we did it. So Solar X automatically stored everything in the SD card. But we were watching the eclipse the whole time otherwise. And yeah, it was really amazing how we saw the moon right in front of the sun. We got some good pictures. But we didn't, as I told you, we didn't see totality visually, but we could experience we could see all the birds flying home and the crickets chirping.
Yeah, absolutely.
Thank you very much, guys. Very well done. Congratulations. Our next speaker is Charlene Norgrove. Here she is.
For this eclipse, I treated them. Thank you. My family and I went to Idaho for this eclipse, and I treated them to this. I flew. This is going to be difficult. I flew to Boise, Idaho, and they drove from California and Nevada, and then we drove 2.5 hours north to Cascade, which was on a lake. I have 5 minutes, so this is going to go fast. I rented a chalet, really beautiful chalet, wraparound porch, 2 fireplaces, hot tub, and we were there for 4 days before the eclipse. So we had all kinds of time to do hiking, biking, fishing, whitewater rafting, and jet boating. So this was the whole experience. Day before, we cut up a pillowcase, we made pinhole cameras. We tried those graders, they didn't work worth a darn. But it didn't matter, that's what you got from the trees. And on the first slide was just through the trees during the eclipse. Okay, so this is the day before the eclipse. This is the view from the chalet out over the lake to the east. Okay, so the clouds were coming around. I was starting to get worried. We took a drive, we went hiking that day, it was lovely. But on the way home, this is what we got. The clouds started coming in, had lots of high clouds like this covering the whole sky. Not all of them are as picturesque as this. But we were really lucky. The day of, look at that sky. Absolutely gorgeous. You know, so, and we just set up right out on the driveway of the chalet. We had an absolutely perfect view. Okay, this is the day after. From the plane leaving Boise, that's Boise, the drive from Cascade Lake down to Boise, the sky was completely gray with wildfire smoke. So we were out there when the wildfires were active. So we were extremely lucky. Okay, but what I want to talk about here is I'm going to follow up on the Nath family's measurements here a bit. And I think that we should probably send them over here to the University of Madrid because they probably did it a whole lot cheaper than they did. I saw online a professor from UBC, posted a diagram online, which is the next slide, and I'll show you. And I thought, okay, where did he get this? Because it's from Cascade, Idaho, this graph, which is where we were. So I thought, what happened here? Well, the University in Madrid had an expedition to Cascade Lake, and they used photometers built for NASA's Transiting Exoplanet Survey satellite to measure things. So what you've got here is the temperature sensor is a green cylinder. This is the test B photometer. These colors are meaningful. I'll show you next time. This is the test W photometer with a solar filter on, a camera, and a light meter. The solar filter is needed to record the brightness during partiality because the test photometers are designed for night sky brightness. So here's what we got. This was the graph. Just about like what you did for $80, right? Pretty good. I was only interested in the air temperature and the brightness of the sky, which was extremely noticeable. Now we were at about 6,000 feet high and forested lake, you know, so the red line is the brightness of the sky. You can see it went from, where'd it go? It darkened by about 9 magnitudes. It went from about 6 down to about 13. 9 to about 13. That's the data from the filtered photometer is in red, and the unfiltered photometer is in green. And recorded that drop. The temperature variation is in blue, and it was recorded with another sensor that's inside the test W, and it dropped by 10 C. At where we were, the temperature at 1 o'clock was 27 C. It dropped to 17 C at 1:30, which is going from 80 F to about 62 F. It was very noticeable. Let's see, what else can I say about this? Oh, the delay. There was a noticeable delay in the brightness. The temperature and the brightness dropped, and the temperature dropped later. That's a real measurement. They measured that difference in the bottom point on that with those expensive instruments. Okay. The other thing, one more thing to talk about, and I'm just about through, that nobody's talked about is this. Okay, about 20 minutes before totality until about 20 minutes after totality, we got eaten alive. We were right next to the woods, you know, and all of a sudden my son's coming over and he's slapping me on the back. I said, "What are you doing?" He said, "Got mosquitoes all over your back." You know, and not before, not a mosquito inside before, not afterwards, just during. So, okay, I got one photo of the eclipse because I was busy with my family. But I'm pleased with it. It's just an amateur photo, but I like it. So, and I didn't do it, this is the color of the sky. I didn't do anything to this photo except try to clear up the eclipse just a little bit. But I was happy because I did manage to get Regulus in there. So I'm happy with my amateur photographer. It was a wonderful occasion for the whole family, and we did get to see totality in between those two cloudy, smoky days. So thank you very much.
So let's move on to Dan Falk. Come on down.
Hopefully this will stay on. I know, my cell phone takes up too much room. How about like that? Okay. Can you guys hear me? Is this okay?
Yes.
All right. Yeah, well, these have been terrific presentations. I doubt that I can top them in any way, so I won't try. I'll just say what I've got. And I also don't have like sort of data. We had like some hardcore science here today, which is awesome. I just have like some pictures and some anecdotes. Okay, let's see. And actually, I've got my little pocket guy. Oh, yeah, okay, it was hard to see. All right, so why this place in Oregon? We actually chose a place called Detroit Lake, and here it is. It's an hour's drive east of Salem, right? So this is Salem, this is Portland up here. Why this location? So I went with my friend Chris, and he and I are both sort of into photography. I'm more the astronomy guy, but after today, he's into astronomy. I'm actually kind of privileged because this is my 5th total solar eclipse. It was the first one for my friend. So why this location? Of course, everybody knows the weather prospects were supposed to be better as you go west of the Mississippi. I think that actually was borne out as it happened. Why near a lake? Well, as a photographer, I like having something pretty in the foreground of my photos, so a lake seemed like a good idea. But there's one other reason too, which I was very concerned about crowds. There are all these articles in the papers, and I guess actually I wrote some of those articles. But anyway, there are a lot of stories saying, "Oh my God, it's going to be crowded. It's Eclipse Mageddon. Everybody's going to be on the interstate, and then everybody's going to be at your observing site, and it's going to be chaos." But I thought, well, if you're by the side of a lake, no one will be in front of you. I mean, unless they're in like a boat or something, and that's a smaller number of people. That was what was going on in my head. Okay. So on the way there, so this is now the day before the eclipse. We're driving south from Portland to Salem. They're getting set up for viewing at Willamette University. Lovely poster. I didn't get a physical copy of it, but I stole their JPEG. I think this is lovely, but of course I wasn't. By the time this happened, I was already at Detroit Lake. But it's kind of cute. We ran into Jay Paskoff. Some of you, I'm sure, know Jay, or at least know of him. He's seen, rounding off here, a zillion total solar eclipses. I've forgotten the number, but it's huge. I believe he is the world record holder. Of course, these records are a little fuzzy, and you never know if people are lying or not, but I don't think Jay, he really has seen a lot. I profiled him for Quanta magazine. The article ran a week or so before the eclipse, and whatever that number is, it's in the article, but I forget, but it's way over 30. And of course, if you count partials and annulars, it's much more. We also talked to some of his students, and God knows how much gear these guys brought, but it's a lot. So now it's the afternoon or the evening of Sunday, so that's the day before the eclipse. And the question is, where is everybody? All these articles that were saying that it was going to be mega crowded don't seem to have been borne out. Now, I'm sure they were borne out east of the Mississippi in various locations. But it really wasn't an issue on Route 22 heading east from Salem towards Detroit Lake. Here we are the evening of August 20th. That's my friend Chris. So far, crowd control not really an issue at this stage. So things are going well. So yeah, we stayed at a motel up the road, which we booked about a year and a half in advance. That was a smart thing to do. I mean, finding accommodations was would have been tricky. But just finding a place to like put a tripod and have room to go like this, that actually wasn't so bad. So the motel is up here at the north end of the lake in the town, very, very small little town. As we were scoping it out the day before, and of course we had looked at the Google Maps and so on, but there's a state recreation area here, and as you know, the azimuth and the altitude of the sun, right? So at eclipse time it was going to be in the southeast and 40 degrees high in the sky or whatever, so you want to have a clear view in that direction. So we figured, all right, this area will be pretty good. We were not at all sure we would be able to park there. It's a campground, and it's set up for people who stay overnight, and it wasn't at all clear that you could just show up and park your car if you weren't one of the campers. So we just, this was sort of how we calculated. We drove 1/3 of the way and said, well, we'll just park, just leave the car on the side of the road, as a few other people had done. Later, there were warnings that, they have this alert system so that your phone goes ping and says what is going to kill you next, right? So the phones were going ping and saying, don't park by the side of the highway because your car could start a fire or something like that. But it was too late. We had already done it. By the time our phones started pinging, we were already down here. But anyway, we parked, we walked. I know the scale is a little hard to tell, but it's more than a kilometer. It's, let's say, on the order of 1 mile, with, of course, all our stupid gear and our backpacks and stuff like that. But nonetheless, I think we did the right thing. It's better than driving here and finding that you can't park and then having to go back there and, wasting extra time. So, as I say, we walk to the Detroit Lake State Recreation Area, where we find sort of an official looking figure. This isn't actually him. This is a representation of a generic figure of this type, who had not been there the day before. When we were scoping it out the day before, there was a friendlier fellow just at the booth giving information about, if you wanted to stay for the campsite, which I'm sure the campsite must have been filled up. But at any rate, so the previous day we sort of scoped it out. But the bottom line is it wasn't really set up for just day use. I mean, there are parks that are for that, but this was an overnight campsite. And I think they were worried about just every idiot from the whole county coming down and deciding they were going to spend the afternoon at this state recreation site. But it was still quite early in the morning, and he was pretty sympathetic to us, and also we were on foot. So we just kind of said, well, we walked all the way from town, which is kind of true, right? We walked all the way from town. Can we please just hang out here for a little bit? And he said, all right, come on in. Now, I don't know what he said to the next people after us. And I guess our backup plan would have been to go all the way, I don't know, wherever, further to the south end of the lake or back to the north end of the lake. The entire lake was in the path of totality, but nonetheless, we wanted this sort of nice spot. Now, this is Eclipse morning. There are some issues, and one of them is fairly obvious, and it was actually hinted at or said in the previous talk, which is the forest fires. So everybody knows that forest fires are a real possibility in the western United States. I knew, I guess, but I just, much like, when your doctor talks to you about like some body part that you don't think of, like, I don't know, your prostate or some other thing, you think, well, whatever. Like the doctor's just gibbering on and on. It's not going to affect. So I thought these forest fires aren't going to affect me, right? And really, we didn't notice anything weird the day before. We didn't notice anything while we were in Salem or in Portland. But now there was definitely a haze. I mean, you can see it in this picture, right? It's kind of a smoky haze, and you could smell it too. It wasn't overwhelming, but it was bad enough that if you didn't have a really good reason to be there, like a total solar eclipse, you probably would just leave and go somewhere else. It was smoky enough that you definitely noticed it. We found out later where the fires were. We actually know the name of it. This one was called the French Fire. I don't know what it's named after, but now we know who to be angry at. But it was quite local. We were told that this fire was about 5 or 6 miles away. So the fire was quite nearby. All right, so I won't bore you with the details of what I took. The closest thing I had to a telescope was just a camera with a DSLR with a pretty good telephoto lens and a bunch of other stuff. But in summary, don't ever try to take all that junk with you to a solar eclipse. I really don't recommend it. And for the main reason being that the more time you spend fiddling with your equipment, the less time you'll spend looking up at the eclipse, which is really what you should be doing. And now, again, I've been to some solar eclipses previously, so I guess it's less tragic in my case than it would be for someone seeing it for the first time. But all those articles that you read in Astronomy and Sky Telescope and Sky News that said, don't take photos, look up at the thing, that was all true. Like, just don't look down at your equipment. It's a terrible waste of time. Okay, so the partial phases went quite well. Oh, I guess an exception to that, what I just said is, as the kids did with the SolarX, if you can automate it, if you can automate everything, okay, that's cool. And if I can, sort of figure out how to do that next time or something, I think that's the way to go, or just set your cameras in video mode or whatever. But if it requires your attention, that's a bad thing. So things went pretty well during the partial phases. I guess this is one of my better photos, just again, DSLR telephoto lens. I can do some frequently asked questions. Dan, the focus is pretty sharp. I assume your telephoto lens maintained its focus over the entire duration of the eclipse. No, not really. Things kind of shifted a little, whatever. But this is not bad. Now we're well into the partial phases. The so-called crowds have built up. I mean, there are a lot of people, but they're spread out. They're spread out in a pretty reasonable way. It's just not like, so in our sort of immediate area, I mean, there would have been 30 or 40 meters between us and the next humans, but there were, I mean, they come clustered, in families or whatever. But anyway, there was lots of room for everyone. You do get a sense of this haze never really left. This kind of smoky haze was there the entire time, but it was not opaque. I mean, we could see through it, but it's just like looking through a thin or medium thin haze. So, and you see it again here. So here we are very, very close to totality. Using one of my 7 cameras, I took this picture. I don't know if it was 7.5, whatever it was, some ridiculous number. And this is actually not bad. I mean, this is a pretty good recreation of what it actually looked like, or what I imagine it probably looked like if I had looked up at it. I'm exaggerating a little bit, but I know it's funny because it's true. Yeah. And here's totality. And that's not bad for a point-and-shoot camera. I mean, it's not going to win any prizes, but it's thanks. So that's not so bad. So let's see. I forgot what else I've got here, but I've just got 1 or 2 pictures left. Okay, so I glued this together, and I probably included the wrong one. So this is, I guess, the bad one where I forgot to blur the boundaries between the each part of the montage, so I think I might somewhere have a better version of this. But at any rate, it's not bad. These are just assembled in Photoshop, all pictures taken with the telephoto zoom lens on my Pentax APS-C sensor DSLR on a sturdy tripod. The pictures are okay. It just took me too long to make sure that they were occurring correctly. This is one of the things that ought to have been automated. And what else? And you can kind of tell, right? There is something a little funny here, right? So these colors, in Photoshop, I did not change the colors in any way. So you can see there is something a little funny going on here. And I would say that this weird reddish coloring has something to do with all the haze, the smoke and the haze from the forest fires. Well, again, mercifully, these are shrunk down to fit them on the top, so you can't really see how bad the focus isn't horrible, but the focus did gradually get worse as the event went on. But it's not bad. And this is, I mean, this is as close as I've got to having like the really good diamond ring picture that everyone wishes they had. But whatever, it's something. It's okay. And again, in a montage, it's not too bad. This is a little while after totality has ended, and you can see the haze is sort of even getting thicker. I don't remember exactly what time in the early afternoon this was, but let's say it's an hour, maybe this is an hour and a half after totality has ended, I'm not sure. But it gives you an idea of just how thick. I grew up in Nova Scotia, so we're used to fog, and it's possible that some of this is fog. I don't know, I'm not an expert on these things, but a chunk of it, I suspect, or I'm actually pretty sure, is also forest fire related. Probably a combination of things going on here. We drove east. I figured we were in that part of the United States. We just went on a long drive over a couple of days after that and visited Grand Teton National Park and also Yellowstone National Park. And I hadn't been to either of these parks, so that was my first time. Obligatory Old Faithful photo, and saw a whole bunch of bison. Felt a little bit guilty about the bison burgers that I've had over the years, but having said that, they were pretty delicious. But it's actually, you can't tell in this photo, but these national parks are very, very popular, and it's almost a bit disconcerting to see the crowds of people. I mean, yes, there's a herd of bison, and I don't know if we outnumbered the bison or not, but I mean, you do get this feeling that we're maybe intruding on their territory. Did a bit of nighttime star trail astrophotography. I do like to do this sort of thing. I haven't figured out how to do it with a digital camera yet, but I do know how to do it with a film camera, so I just did it the old school way. I like to pretend it's 1983 or something, and that's roughly the epoch that my SLR is from, and did some time exposures. Took a whole bunch, most of which are not worth showing anybody, but I sort of got two reasonably good ones. The film that I used to really like for this was Provia 400. They no longer manufacture it, so the closest thing that you can get is Provia 100, and then you take it downtown and tell them to push it 2 stops, and you pay extra for that. And the cost of it, I won't go on and on about it, but the cost of this hobby has gone up kind of a lot recently. Yep, that's it. Thanks very much. I'm happy to.
Questions for Dan? No questions, yeah?
I was so clear there. All the questions have been answered.
Sorry,
Perfect.
one.
Oh, yeah. Hey.
More a comment, Dan.
Okay.
Your concern about crowds was thoroughly justified. We were just south of Salem, and because of the crowd warnings, we went to our site just several hours beforehand. So we arrived there in the dark with the whole family, with little kids and everybody else, and it was okay coming down. It turned out that we were living or staying in Portland. It took us an hour to get there, just like Google Maps said it would. Going home, however, after the eclipse, and this is well after the eclipse, it took us 6 hours to get the 1 hour drive to get back, because everybody's back on the interstate.
Yeah.
To get back at the same time.
Yeah.
I've heard stories of similar things, that going to the eclipse was relatively good.
Yeah.
Coming back from the eclipse was a nightmare.
Because everybody wanted to get home by dinner time.
Right, and people knew enough to get there early, but still wanted to bail out. And I had read, there are all these maps about the so-called choke points, right? People had predicted, it's where the interstates, where the north-south interstates, of which there only are a few, intersect with the path of totality. That's where the crowds are going to be. Apparently this was correct. And we saw on the news, so we stayed in Detroit Lake, and luckily we were there 2 nights, so after the eclipse, we didn't have to drive anywhere. We just had to sit down and watch TV. So we saw pictures of people trying to drive home to Portland, from Salem to Portland, and that apparently, as you're suggesting, was a very, very long wait for those people. As for the folks I don't know how crowded it exactly was in Salem, but if you say you were a little bit south of Salem, right? So you were probably very close to the center line.
We
right?
were the closest place. We looked up all the vineyards that were hosting this.
Priorities.
And we found the one closest to the center line, and they still had room, and so we looked into that. But that also limited the crowd, because they would only take 500 people under this whole vineyard.
Yeah.
So it was perfect for us. But the smoke was all the way around, and it had sort of enhanced the 360-degree sunset. But we didn't smell it. We were up above it more, I think.
Oh, okay.
than you
Yeah.
were, but-
I mean, so from seeing what people posted from Salem, I think they had very, very good conditions, as far as I know. But yeah, I don't know if I had sort of especially bad luck with forest fires, but I mean, I can't be the only one. Again, there were forest fires in Idaho. There were forest fires in a lot of different places. I think the people in Grand Teton in Wyoming had really, really good views, but yeah, it's hard to predict exactly the best place to go.